deals with the formula. All right, so we did a table, a graph, and now here's a formula that will model the distance our car has traveled after t months. So where do the input and the output go? So t is the input, so it goes on the inside. And on the right, when you plug in t, this thing gives you the output. So the output goes on the right-hand side, like this. How far has the car been driven by the end of February? Again, the end of February, t is equal to 2. And so all we need to do is crunch d of 2, which equals 250 times 1.403, right, to the 2. And put this into our calculator and see what we get out. All right, so to do that, pull up the calculator here. All right, so on the calculator, we just hit 250, right, times 1.403. Right, so 403. And then we're going to raise that to the 2 and hit enter, and out pops our answer, and we'll just round to the nearest mile. So this is approximately 492 miles. All right. And then part C says by how many miles were put on the car from the end of July to the end of September. Right? So you have to remember the end of July corresponds to t equals 7. And the end of September, right? Well, 7 is July, 8 is August, and so t equal 9 is September. And to figure out how many miles were put on from July to September, the first thing we'll do is calculate the distance, the number of miles the car had on at the end of September, and then we'll figure out the number of miles the car had on at the end of July, and then subtract these two values to get our final answer. So d of 9 would be 250 times 1.403 to the 9th. And then d of 7 would be 250 times 1.403 to the 7th. And so this one is equal to, so on our calculator, you can just hit second enter to pull up the last entry and change this 2 to a 9. And we get out 5,265, and let's just write it all out, 33559. And then when we plug in 7, again you can hit just second enter and pull up the 7, replace the 9 with a 7, and we get this to be equal to 2,675.122695 miles. And then we take these two mileages and subtract to find how many miles were put on from the end of July to the end of September. So I take 5,265.73559, and I'll just take away the last answer, so second answer. And I'll round this to the nearest mile, so this is approximately 2,591 miles. Now the last problem, it says how many miles were put on the car over the entire year, and it asks if this is close to our previous answer. So to figure this one out, all we need to do is figure out what does it mean by an entire year. So this is t equal 12. And so we want to find d of 12, which if you look up at your formula, it's equal to 250 times 1.403 to the 12th. And I can put this into my calculator again. I'll just hit second enter, and hit second enter again. I'll pull up the one before that, and I replace the 7 with a 12. I hit enter, and I get my answer of approximately, I'll round this again to the nearest mile, so 14,542 miles. Okay. Is this close to my previous answer? Well, I have to go back. Right? I have to go all the way back here to the first page and look. And so I got about 10,000 miles here. So maybe I'll say, not very close, really. Right, so in this case, not very close. because off by almost 5,000 miles, right? So not very close to my previous answer. And down here I can fill this in, express as functional notation d of 12, and I can write as approximately 14,542 miles. And then now the last part here are write down some pros and cons of each. So we want to kind of compare and contrast these three different ways of understanding what a function is. So from a table, graph, and a formula. And so, for a table, tables are pro. They're easy to read. They're easy to read. It's easy to see increasing and decreasing. Easy to see increasing or decreasing. Right? If the outputs go up, it increases. The outputs go down, they decrease. It's hard to see concavity. Right? It's really tough to visualize if it's concave up or concave down. It's also hard to do interpolation. Right? Hard to do interpolation. Right, so interpolation, remember, it's estimating values inside your table. So if you're not given the actual data point, right, you have to have some sort of method to estimate what's going to happen, and that's not so easy to do. It's hard to do extrapolation too, so you could write down extrapolation next to that also. For a graph, it's also, for the most part, pretty easy to read. Right, it's easy to look at and read. It's also very easy to see increasing, decreasing, concave up, right, and concave down for the most part. Right, these are pretty easy to tell. Again, it's actually pretty easy to do interpolation on this too. Right, so if you want to add something else, right, you can call this 1, 2, and then 3. It's easy to do interpolation. Right, remember, to do the interpolation on a graph, you just point to the point on the graph. Right, it's hard to do extrapolation though, right, because you don't have a graph for it. So this is hard to do. It's hard to do extrapolation. Because there's no graph. Remember, extrapolation is estimating what's going to happen outside of your data, so outside of the graph. So it's not so easy to do this. Formulas, pros, you really don't have to guess, right? You never have to guess, really. Never have to guess, right? Because you can just plug in the value. Because you can just plug in. So it's easy to do interpolation and extrapolation for the most part. Right? It's hard to see increasing, decreasing, concave up, and concave down from a formula. Right? Unless you know exactly what that formula is doing, you understand all the numbers in it, you can't really tell if it's increasing, decreasing, concave up, or concave down. You could also write stuff, sometimes they're complicated to work with, right? If you don't know how to put it into your calculator correctly, you can't crunch the numbers.